Hello everyone, hope you all are doing well. So now we will start our new topic, that is defects of Neil Bohr. Previously we have done the Neil Bohr main points, its experiment, and the main points, or you can say the postulates of Neil Bohr. After that we calculate its radius, energy level in different orbit, the number of waves and frequency. But now we will take out the defects, or you can say drawbacks of Neil Bohr, that what he did wrong, by which the next you can say scientists have researched about it and make him wrong. So he just explained, first point is that he just explained about monoelectronic monoelectronic atom, or you can say ion system, or ion system. What is mono means? Mono means one, means he just explained about the one electron over there, not more than one. Likewise, I should give you example of hydrogen over here. Like hydrogen, it's having one electron. So he just give the example of one electron, means monoelectronic atom. He just explained, like we can take helium. We are having two electrons, we are having plus, so it means it's lost one electron, so it's also having one electron remains. Like we are having lithium. Have three electrons, two its lost, we are having one electron remains. So he just explain and experiment on the monoelectronic atom of ion system, by which he was right in the monoelectronic atom or ion system. But the scientist asked that to explain him the polyelectronic atoms, means we can write here, he didn't explained polyelectronic atom or ion system. Now what is poly? Poly means more than one. Scientists ask him to explain more than one electron. Like there in lithium, we can check out if it's not losing its electron. So there are the three electron in lithium. But he just explained about the one electron, like monoelectron. Helium having two. So that's why he just failed in this one. First drawback of that is First drawback of Neil Bohr is that he didn't explain about the polyelectronic atom or ion system. After that, move to next. He said that electron revolves in circular path. Till here, everyone was just listening him and just agree with his point that electron revolve in circular path. But when he say that with two dimensions, so he just get wrong over here. Like he was saying, okay, here's a nucleus over here. Okay, I can make it. Here's a nucleus, and it's moving in a two dimension, like x-axis and y-axis. But it was wrong. According to the new research, means latest research said that he's right that electron revolve in a circular path, but with three dimensions, not at all two dimensions. So he was again wrong over here, that he didn't explain that how it moves in the two dimension, why not three dimension. So according to the latest you can say, I can make over here a diagram. Latest research, here is a nucleus and electron. They said it's moving in a three dimension, like x-axis, y-axis and z-axis. X, y and z, these three axes. So he was just get wrong over here. After that, what he did, that he did one experiment with a device that name is a spectrophotometer. He take this one device, is a device that he take. Okay, he take this one device, and by its radiation, you can use any radiation over here, like ultraviolet rays or gamma rays, or like this, Okay, so what he did, that he take the monoelectronic atom, like we are taking hydrogen, okay, and then he just heat up that. Let me make a diagram. Like here is one bowl, okay, here is three lines, K, L, M, N. I should write here K, sorry, not from here, here K, L, M, N. So here is a hydrogen, okay, hydrogen, and here is the electron of hydrogen, means in a K shell, because it's having one electron just. So here is a helium gas, here, okay, not helium, a spectrophotometer device is here that is giving radiation. What happens, that when it's heat up, so this electron move to upward, means to L, to M, to N. But when it's moved to the last one shell, so it was unstable. When it was unstable, so it directly again came down, like cooling down, or you can say move downwards, means it's move upward. When it was unstable, so it again move downwards. Now what happens, that when it moves upward with the heat, so what he observed, he observed a absorption line spectrum. This line is called absorption line spectrum. That is not a colorful, that is in a black color. Should I write here, absorption light spectrum, absorption light spectrum, having black color he have seen here, okay. But one more thing he have seen, that like it was black color, but when it the light again, this line came downwards, means when it's unstable and it's come downward, so he just see that he give a name of that one line is emission line spectrum. And this line was colorful, by which he see, means in spectrum we can see. So with that he see, check out that how these two lines are coming. One line going, it's called absorption line spectrum, and second line is coming, that is emission line spectrum, okay. So this was the experiment he did with a spectrophotometer device, okay, to find the monoelectronic atom. But one more thing, after that, his this one theory was also wrong, that there are two scientists, there's a two effects of scientists, they study more about line spectrum, and what they search it out, that Zeeman effect. Firstly we should talk Zeeman effect. What Zeeman effect does, that he study about more about line spectrum, okay. When he studied more about line spectrum, so what he did, he passed that line spectrum from magnetic field. From which field? Magnetic field. And what he see over there, like this is a line spectrum, okay, and this is a south and north pole, you can say magnetic field. After that, what happens when magnetic line spectrum pass from the magnetic field, so what he observed, that here two lines, here these lines are splitting out into other lines, okay, and these lines making orbitals like SPDF shells when having high magnetic field, so more high orbitals and suborbitals like that. So this line split it out into different sides, okay. So just Neil Bohr didn't explain this one, that how this line you can say split out after the magnetic field, and what this line is. After talking about Stark effect, Stark also read a study about line spectrum. So what he did, as Zeeman passed from magnetic field, he passed from electric field. So he observed the same thing over there. Means that when he passed from the electric field over here, like positive and negative, he also see the same thing, that when it passes over here, it's splitting into different lines, means thin, or you can say different fine lines. After that, the this one also wrong of Neil Bohr, that Neil Bohr giving the experiment of a spectrophotometer device. So these are the drawbacks of Neil Bohr, that he did, and his experiment got wrong. his discovery got wrong, and then another scientist came and discovered more about the electron. Hope you understand today's lecture. Thank you so much for listening.